All right, so today I just wanted to review like what we talked about before break. That's part of Unit 6, and then we're going to continue with Unit 6, okay? So if you remember, we started talking about basic integration and things like that, so let me just review. So first we did basic integration. Okay, so this included a few things. First of all, the constant rule, the integral of k dx is just kx plus c, right? The integral of k times f of x, constant multiple rule, is just k times the integral of f of x dx. So you can just consider the constant to be outside the integral, just like with derivatives, right? If you have a derivative of a constant times a function, it's like the constant times the derivative of the function. Same thing goes for addition and subtraction. If you have f of x plus or minus g of x, you can just think of them as separate integrals. Take the integral of f of x plus or minus the integral of g of x. So these rules were all kind of leaning towards being able to integrate polynomials. So the final step of that is the power rule. If you have x to the n power, then its integral is x to the n plus 1 divided by n plus 1 plus c. So you should be able to integrate any polynomial or expression with radicals or negative exponents or whatever. So if I have something like the integral of 5x to the 7th plus 8 over x cubed minus 3 radical x plus 8 or something like that, dx, you just integrate piece by piece. The first piece would be 5x to the 8th over 8. This is really, the second term is really 8x to the negative 3. So this would be 8x to the negative 2 divided by negative 2. You add 1 to negative 3. All right. The next term is 3x to the 1/2. So it's going to be minus 3x to the 3/2 times 2/3. Right. Dividing by 3/2 is the same thing as multiplying by 2/3. Plus 8x plus c. Don't ever forget the plus c. If it's a free response question, which is it's a little bit rare to have an indefinite integral like this on a free response question, but if you forget the plus c, you won't get full credit. Okay, so you don't want to ever forget that. If it's multiple choice, they'll almost always have it there, so you don't have to worry about that so much. There's a couple other basic integration rules that you need to know. The exception to the power rule is if you have 1 over x, so if n is negative 1, and this is just ln x plus c. And if you have an exponential function, e to the, I'm going to say e to the kx, this is just e to the kx divided by k plus c. And then we have 6 trig rules. Okay, so they are the integral of sine kx is negative cosine kx over k. The integral of cosine kx is sine kx over k. The integral of secant squared kx dx is tangent kx over k. the integral of cosecant squared kx is negative cotangent kx over k plus c. I'm just hurrying through this because hopefully you remember them. And then there's two more. The integral of secant kx tangent kx is secant kx over k. And the last one was the integral of cosecant kx cotangent kx is negative cosecant kx over k. So any questions on those basic rules? Got 6 trig rules. You got the power rule, and then rules having to do with constants and addition and subtraction. Remember, there's no product rule. There's no quotient rule as it relates to integrals. So sometimes you'll have something that's a little bit deceptive. Maybe they'll give you something like the integral of like 5x squared minus 2x over radical x. And they're trying to tempt you into doing some sort of quotient rule that doesn't work. This definitely would not work with the quotient rule. What do you have to do instead? Yeah, you kind of just think of it as like 2 separate fractions and simplify the exponents. So you think of it as like this fraction right here, which x to the half divided by, or sorry, x squared divided by x to the half, you would subtract exponents, and you would get 5x to the 3 halves. And then same thing, you think of this as a separate fraction. So it's going to be x to the first divided by x to the 1/2. You subtract exponents again, so you get 2x to the 1/2. And then you just use the regular power rule to integrate, right? So this would be 5x to the 5 halves times 2/5 minus 2x to the 3 halves times 2/3 plus c. That would be the answer. So this is a really common thing that students mess up. So try not to mess up that situation. Okay? Any questions on just basic integration? Okay, after that we talked about definite integrals, or FTC part 1. Definite integrals. Fundamental theorem of calculus, part 1. So remember, the fundamental theorem of calculus, part 1, is just telling you how to evaluate a definite integral. That's all it is. It's just a recipe of what to do. Just a process map or whatever. So if you have something like, if, how do I want to write this? If f of x is an antiderivative of f of x, then the integral from a to b of f of x dx, lowercase f, would be f of capital F of b minus capital F of a. That's the fundamental theorem of calculus, part 1. Just tells you what to do. You take the indefinite integral and you just plug in b, plug in a, and you subtract the 2. It doesn't matter which number is bigger or smaller. Usually this would be the smaller number, that's a bigger number, but it doesn't have to be that way at all. But it does matter which order you subtract them in. It has to be the top number first, then the bottom number. Okay? So if you had something like, for example, the integral from 0 to pi over 3 of sine 3x. Remember, the notation is you take an antiderivative, which would be negative cosine 3x over 3. And then you put a little vertical line from 0 to pi over 3. And when you read this, you would say the answer is negative cosine 3x over 3 evaluated from 0 to pi over 3. That's the way you do it. That's the way you read it. And then you just plug the numbers in. So this is going to be negative cosine. If you plug pi over 3 in, you get pi over 3 minus negative cosine 0 over 3. And you always have to be careful, especially since this is subtraction, with sign errors. You got to make sure that you keep track of pluses and minuses. There's a lot of places to make little mistakes. So the cosine of pi is -1. Negative cosine pi would be +1. So that's 1/3. And then it's plus, because there's two negatives, 1/3. So the answer here would be 2/3. And remember, your calculator will do definite integrals for you. So just as a reminder of how that works, let me make sure that the mode is in radians. It is. So there's two ways to do it. From the main working screen, you can just do math 9, which is definite integral, and you just type this stuff in. So the integral from 0, then press the up arrow to pi over 3. The function is sine 3x. And then you have to just type in dx, because these calculators have more capabilities than we're going to use them for. You got to make sure it's a dx. And then just press enter, and it'll do it for you. It's 2/3. Okay. The other way to do it is you could graph the function. So if I graph sine 3x, you have to graph the function in the domain that you're given, or at least including that domain. So you could be bigger than that. Like I could just do zoom trig or something. That way it'll be more than I actually need. And then I just do second calc, and choice 7 is definite integral. So choice 7, they'll ask you for the lower limit and the upper limit. The lower limit is the bottom number, the upper limit is the top number. So it would be from 0 to the upper limit would be pi over 3. And then it'll calculate that definite integral for you. Okay, so two different ways to do it on your calculator. You need to be comfortable with doing it on your calculator. And remember, the shortcut on your calculator is if you've already typed in the function and you're on the working screen, you could just do math 9 from 0 to pi over 3. Instead of typing in the function, which this function is not that complicated, but sometimes they will be, you can use the vars key. You can do variables, y variables, function 1, and it'll automatically take whatever you typed in as function 1, dx. Okay? Any questions on that then? Definite integrals. Okay? The next thing we talked about in Unit 6 then was U substitution or integration by substitution. So let's just do a couple examples of this. Like for example, if you have something like the integral of e to the tangent x times secant squared x dx. What do you think u should be? Tangent x. And remember, what you're looking for is you're looking for something whose derivative appears as a factor of the integrand. The derivative of tangent x is secant squared, and there it is right there as a factor of the integrand. That's the key. That's what you're looking for. And then another helpful hint is sometimes it's something that appears in parentheses or implied parentheses, and that's kind of the case here as well. So you'd say u is tangent x, du is secant squared x dx, dx is du over secant squared x. Then you make the substitution. This is going to be the integral of e to the u times secant squared x times dx, which is du over secant squared x. They cancel. Anything with x's in it should cancel. If it doesn't, then there's a problem, right? You either selected the wrong u to begin with, or you might have to do some sort of substitution that involves what you let u equal in the beginning. Like sometimes what you can do is you can take your definition of u right here, solve for x, and then plug that in so that you have just u's, but that's a little complicated. This isn't one of those. So this would just be the integral of e to the u du, which is e to the u plus c. And then the final step, don't forget the final step, is to substitute back in to u's. If you leave it like that, or back into x's, if you leave it like this, it'll be wrong. So this is going to be e to the tangent x, and that's the answer. Okay, let's do one more example of u substitution. So what if it was something like the integral of 1 over radical x times 1 plus radical x squared. What do you think u is in this case? Don't be shy. Just yeah, it's 1 plus 1 radical x. Because if you think about what the derivative of that is, it's 1/2 x to the negative 1/2. Here's an x to the negative 1/2 right there, which is a constant multiple of the derivative of the u that I think it is. You know what I mean? So that's what you're looking for. You're looking for a factor of the derivative of u, or a factor of a constant multiple of the derivative of u, and that's what's happening here. So u would be 1 plus radical x. Du would be 1/2 x to the negative 1/2 dx. So dx equals, it's going to be 2 radical x du, right? Because right now the 2 and the radical x are in the denominator. So you got to multiply them to get them over on the other side. So this is going to be 1 over, integral of 1 over radical x times u squared times 2 radical x du. And the x's cancel. So this is really 2 times the integral of u to the negative 2 du, which is 2u to the negative 1 over negative 1 plus c. So the answer is negative 2 over u, negative 2 over 1 plus radical x plus c. Remember, there's also a shortcut for u substitution. If the u that you're going to pick has a derivative that's just a constant, you can save yourself a ton of time. For example, suppose it was something like the integral of cosecant squared of 7x minus 1. I know that u should be 7x minus 1, and I know that that'll work if I use u substitution. But I could save myself a lot of time by not using u substitution and just saying the integral of cosecant squared something would be negative cotangent of that stuff. So all you have to do is then just divide by the derivative of the u that you were going to pick, which is 7. And that's it. That's the answer. So you save yourself all that work by doing that u substitution shortcut. Okay, so don't forget that that's an option, only if the u that you're going to pick has a constant derivative. Okay, that's the only way that that works, but it's pretty often. It happens. They'll rig it like that to help you save time. Okay, any questions on that? Then one more review topic that we did before break was integration that involves inverse trig. Integration with inverse trig. So remember, there's basically three things that you need to remember, three rules. Not six, because they end up being negatives of each other, and you can just have it be negative instead of worrying about the other ones. So if you have the integral of 1 over the square root of 1 minus x squared, this is inverse sine x. Let's see. The second one, and I get these confused. This is one of those things that even if you're good at it, like this is something you should look at just before you go into the AP test. Because there'll probably be one on there, and this is the type of thing that you don't want to spend a lot of time like trying to think about or trying to derive what the actual formula is. 1 over x squared plus 1. This one's inverse tangent x plus c.
I think these are easier than memorizing just like the derivative of like cosecant and stuff like that.
Oh, really?
I think these are way easier.
Oh, okay. Not for me. But I don't know. Maybe it's just for me. How many of you feel that way? Which one's more difficult? The regular rules? Raise your hand.
Yeah.
Or the inverse trig rules?
There's not that many of these. No.
Yeah, I don't know. I feel like these ones are just
Yeah, I got mixed up
memorized
with,
for some reason.
Okay.
I mixed up with like the ones that have like cosecant in like tangent and cosecant, or
Yeah,
whatever one that is.
yeah.
I
Okay.
think it's just hard for me to recognize these sometimes. Like the one that we just did with 1 over radical x, I might instinct it's like, oh, is that inverse? But like I can always.
Yeah. That's the problem I have too. Like if I just see a random integral like that looks like that, my mind doesn't immediately jump to trig. Whereas if the integrand contains trig, then I'm thinking trig, and then I'm more likely to like come up with it. Just a random multiple choice question though. Although look at the choices, and sometimes that's a hint. Like the choices will have inverse trig, so it'll put your mind there. But if this is like a free response question where you had to do something like with this, I don't know that I would think of that immediately. I'd first think like, could it be U substitution? Could it be something else? And I'd waste time that way. But anyway, all right, so then the last one is the integral of 1 over x radical x squared minus 1 is secant inverse. And sometimes you have to do a little bit of like algebra manipulation type stuff to get like one of these forms. For example, suppose you had something like the integral of dx over square root of 9 minus 4x squared. I mean, this kind of looks like inverse sine, but not exactly. So you have to kind of make it look exactly like inverse sine. So, bless you, whoever did that. You're throwing your sneeze. What's wrong with this, quote unquote wrong, is that this is a 1 and this is a 9, and that can't be a 9. So that's kind of the way my mind is thinking. Like, that can't be a 9. The way to get rid of that is by multiplying by the square root of 1/9. Because then I can distribute it and it'll make that a 1. But whatever I do on the bottom, I have to do on the top. So that's my thought process in a problem like this, is I gotta make that a 1. So now if you rewrite this ends up being, well, the square root of 1/9 is just 1/3. That's a constant. It can go out front. On the bottom, this square root of 1/9 can be distributed into this radical because they're both radicals. And you get square root of 1 minus 4/9 x squared, which is really 2/3 x squared. Now it's like that shortcut rule for u substitution that you can use. This is just going to be 1/3 of inverse sine of 2/3 x divided by 2/3. So the final answer ends up being 1/3 divided by 2/3 is 1/2. So this is 1/2 inverse sine 2/3 x plus 6. And like I said, I mean, I'm not an AP writer, but more than likely, in the way it has been historically, there'll be like one multiple choice question on this. And if you know it, like there's another question you got right. And if you don't know it, there's another question you got wrong. I mean, I hate to be the one to state the obvious, but that's kind of the way it is. So you want as many of those things that you know as you can, like when you go into the test. Okay? Let's just do one more example. How about something like the integral of sine x over 1 plus cosine squared x? So what do you think you do here?
So this is just like like 1 over 1 plus x squared, which goes to 10.
Yeah, okay. So how do you make it like that?
Use it.
Yeah, this is straight up u substitution. If you have u equal cosine x, then it's going to be 1 plus u squared on the bottom, right? And here's the derivative, or a constant multiple of the derivative of u right there as a factor of the integrand. So yes, u is cosine x, du is negative sine x dx, dx is du over negative sine x. So this substitution would be sine x over 1 plus u squared times du over negative sine x. Those cancel, and the only thing that's extra here is the negative sign. So the answer is just negative inverse tangent u plus c. So it's negative inverse tangent of cosine x plus c. Okay, so those are the 4 basic topics we talked about before break. Basic integration, FTC part 1, which is evaluating definite integrals, u substitution, and then these inverse trig kind of weird problems. That's it. Any questions? Okay, so tonight's homework is on Delta Math, and it's just like a review assignment, reviewing these 4 topics. And then tomorrow we'll pick up with new topics. I feel like this unit is maybe like the longest unit in terms of like the number of topics. Although it's not the longest, it's not the most important unit in terms of the percentage of the AP test that's on this topic. So it's a little strange, but we gotta spend the time just so that you know how to do these, right? We're in like really, really good shape time-wise. I feel like, I've said this before, but I feel like by the end of February or so, we'll be like completely done with Unit 8. And we'll just be able to review and do problems and practice tests and stuff like that. You guys are gonna do really well.
What percentage of total material do you think we have like gone through?
In terms of like the percentage of questions on the AP test,
Or like.
or in terms of
calculus A, B?
time-wise,
Oh, yeah.
if I had to say like the percentage of AP material, AP test material, we've probably covered 70%. In terms of time-wise, we've probably covered like 80%. So we're in good shape. You guys are gonna do really well.
Wait, there's 10 units?
8.
8.
Yeah, and this is unit 6. So we're good. The last units are just about applications of integration, pretty much. But they're kind of easy. especially Unit 8.
What units that are there that we aren't learning that are in Calc BC?
They talk about like polar functions and doing calculus with them, and also complex numbers and complex functions and integrals and derivatives of them. That's pretty much it. But it would take a little, longer than we have probably to do a good job. What some people do, what some teachers do, is they'll go through BC, or they'll have all their students take the BC test, even if they don't get through all the BC stuff, because what the College Board does is it'll give, it gives you 2 scores when you take the BC. It'll give you your BC score and then your AB sub-score. And so the AB topics that are on the BC test are like the same level of difficulty and really the exact same questions that are on the AB test. There's just more of them on the AB test. So it's a strategy that some students use that I think is a little cheating, but they'll take the BC test and they'll just skip all the BC topic questions just so that they have more time to do the AB questions. So they'll get their BC score and it'll be like a 2, but their AB sub-score will be a 5. And then
Does that count as a 5?
depends on what college you go to. I think if I'm a college admissions guy, I'm gonna be like, this person is like trying to game the system. You know what I mean? They just did that so they could have more time on the AP topic. So, but that's what some students do just to get a 5 on the AP, on the AB part. I wouldn't recommend that, and we're not doing that
I
here.
mean, we could just take the BC and just skip the BCs anyway.
That's what I just said. Some
Yeah,
people
but
do. I just said that that's a lack of
even though you're not
integrity.
doing it.
What's that?
Even though like we could still take the BC test, couldn't we?
Yeah, I mean, anybody could take like somebody who's not in this class could say, I want to take the AB test this year or the BC test this year. They could do that. It's at the same day, on the same day at the same time though. So you have to choose one or the other. All right, I'm gonna stop recording.
I don't know.
Get to see you